As mentioned earlier, the SPI protocol was developed by Motorola and became a de facto standard. However, there's no governing body like IEEE or anybody else that is overseeing the standard. So there are some missing information, and the most important three are the following. So the role of the slave select signals, it mainly is to select the slave, but a lot of devices use it as a control signal. So a lot of devices expect to see some sort of an edge on that slave select. So it expects to see something going from 1 to 0, getting asserted, so that it loads the data that it should send to the master to its own internal shift register. And when it finishes, basically when it sees the other edge, it just knows that it's stopped. So a lot of devices use it as a control signal as well. So what you get from this is the following. Even if you're only having one master and one slave, you should connect the slave select signal from the master to the slave, because asserting and deasserting this particular wire or this particular signal actually indicate to the slave that it needs to actually do something. It uses it as a control signal. Not all peripherals do this, but a lot do. So for simplicity, just connect them all the time. The other two aspects are actually pretty straightforward. So the number of bits you send in one data exchange is not defined. It's not 8 bits or 7 bits or something. We have seen 8 bits in all the figures and the diagrams we've seen, and maybe I've showed you an example with 3 bits, but it just is really not defined. So you can actually have it 8 bit, 9 bits, depending on what you're trying to send. And the last one is actually the bit order, whether you send the most significant bit or the least significant bit first is also not specified. So you need to consult with the data sheet and with the peripheral and the slave you're trying to communicate with before you actually set all these aspects.